Hello and welcome to the channel. In this video, I'm going to introduce you to a very interesting research called as iSheep. In this paper, the researchers have emphasized and formally introduced a challenging task, continuous self-alignment with nothing, which aims to explore how to achieve and what extent self-alignment can be realized. This actually reminds me of a Seinfeld show where both George Costanza and Seinfeld are trying to create a show with nothing. But that proves out to be quite good. So I'm hoping that this iSheep is also as good as that show was. So iSheep is a framework that enables continuous iterative improvement of models without relying on external data, tool, or models. iSheep leverages the inherent generation and comprehension capabilities of models. It uses a self driven data synthesis process for data generation and the self assessment process for assessing data quality. Based on these assessment scores, high quality data is filtered and used to train the model itself. And their experiments demonstrate that models can continuously and iteratively improve using iSheep with varying potential for improvement depending on the model size and the level of metacognitive self assessment. They have also conducted extensive ablation studies to verify the impact of filtering threshold, filtering methods, and data sizes on performance of iSheep. Also, I have done various videos on ablation. If you're interested, I would highly suggest that you have a quick look there. If you look at how exactly this pipeline of iSheep is working, you can look at this diagram where the iSheep framework is taking the base model and small seed data set as input. It then aligns the base model iteratively from scratch independently and finally obtains the self-enhanced models and high-quality synthetic data sets. The iSheep framework consists of four main components. The self-synthesized process generates instruction pair data. The self-assessment assesses the quality of the resulting data. The filtering component filters out low-quality data based on self-assessment, and the training component integrates the high-quality data into the base model. So, in my opinion, this is really addressing some of the fundamental issues at the moment because imagine you have a very smart computer program called a large language model. It can understand and generate human like text, but it's not as smart as a human and needs to be trained to do specific tasks. Current methods for training LLMs are like giving them a big book of knowledge and telling them to memorize it. But humans don't learn that way. We learn by practicing, reflecting on our mistakes, and improving ourselves. That is where this seems quite interesting because this introduces a new way of training LLMs called iSheep. iSheep stands for Iterative Self-Enhancement Paradigm. It's like a feedback loop where the LLM generates its own practice exercises, checks its answers, and improves itself based on its mistakes. This approach makes the LLM more autonomous and self-aware like a human. It can learn and improve continuously without needing a lot of human supervision or labeled data. iSheep enables LLMs to self-align from scratch without external data or supervision. It improves LLM performance on various tasks such as question answering and text generation. The approach is data efficient and can reduce the need for manual labeling. The way it works, you can see on the screen that it is generating its own practice exercises, which is instruction output pairs, and then it checks its answers and filters out incorrect ones. It trains itself using the correct answers, and then the process repeats iteratively, allowing the LLM to continuously improve. The paper primarily draws inspiration from educational research on metacognitive self assessment. This means that humans reflect on their knowledge and skills, manage their cognitive resources, and improve their performance. iSheep applies a similar approach to LLMs, enabling them to monitor and manage their learning process. So that's pretty much it. I hope that that made sense. Let me know what do you think about this paper. I think pretty good effort in terms of the realistic approach and addressing the real world problem. If you like the content, please consider subscribing to the channel, and if you're already subscribed, then please do me a favor and share it among your network as it helps a lot. Thanks for watching.